given that the sum from k equals 1 to n of k is n times n plus 1 over 2, and with the result that the sum from k equals 1 to n of k squared is n times n plus 1 times 2n plus 1 all over 6, let's find a way to write the sum from k equals 1 to n of k plus 1 times k plus 2 in simplified form. Okay? So first thing we're going to do is expand through these two brackets, and so we can write this equivalently as the sum from k equals 1 to n of, if we distribute these two brackets over, we're going to get k squared plus 3k plus 2. And now, when we have our summation written in this form, we can break them down into 3 different terms because of our sigma notation properties. And so we can write this as the sum from k equals 1 to n of, because we have 3 terms added together, we can take the sum of each term individually and then add those sums together in the end once they're simplified down. And so we'll do the sum of k squared plus the sum from k equals 1 to n of our second term, 3k, and finally the sum from k equals 1 to n of our last term, i.e. just 2. And now we know the expansion of our first sum, that's the sum from k equals 1 to n of k squared, which we are given up here. And so we can write this one out, and we'll have n bracket n plus 1 bracket 2n plus 1 all over 6 plus one of our sigma notation properties is that we have, when we have a constant that is multiplying through our variable term, we can pull the constant outside, and so we can have the 3 be outside, and then the rest of it is simply the sum from k equals 1 to n of k, right? If we pull the 3 outside, all that's left inside is k, and so our first result is going to give us this expansion, and that becomes n times n plus 1 all over 2. And finally, our third summation, the sum from k equals 1 to n of 2, that's simply 2 added n times, and so that's 2 times n, or just 2n. And so now we've brought our initial summation into 3 different individual summations, and we've expressed those in simple terms. So now all we have left is we need to get all 3 of these terms together into one to make one nice result. So let's go ahead and do that. Here we have a common denominator of 6, 2, and 1. So we're going to look for a common denominator for 6, 2, and 1, since there's none on the last one. And so we know that that common denominator is going to be 6. So we can leave the first term as it is, and we can multiply our second term by, let's say, by 3 over 3 times 3 over 3. And the last term, if you want to conjoin it with the denominators of 6, let's multiply this by 6 over 6. And so now we can write our expression as n times, let's distribute through the 2 brackets here, because we know we're going to have to eventually. We know we're going to have to eventually. So we'll have 2n squared plus n plus 2n, so plus 3 n plus 1 all over 6, plus, we're multiplying the top and the bottom by 3. So we know we'll have our common denominator of 6, which is what we wanted, and on top we'll have 3 times 3, which is 9n times n plus 1, and then our third term will be 6 times 2n over 6, and that is 12n over 6. Now, let's keep going until we're done simplifying our expression. And so, let's multiply through by n now. We're going to get a cubic function out of it. So n times each term inside the bracket gives us 2n cubed plus 3n squared plus n all over 6 plus, let's multiply 9n by the bracket n plus 1, and so that will give us plus 9n squared plus 6, and plus 12n over 6 at the end. And now you can see we're getting towards the end of our solution. We have our common denominator, and so we can sum up our numerators. And so we'll have 2n cubed plus 3n squared. Let's combine like terms, or at least group them together so that we can more readily simplify in the end. 3n squared plus 9n squared. And then next, let's do the n. 1n plus 9n plus 12n. So n plus 9n plus 12n. And we know that all of these terms are over a common denominator of 6. And now we can go ahead and simplify a little bit. So we have 2n cubed plus 12n squared plus 22n all over 6. And we can divide everything by 2 to simplify down a bit. So divide by 2, divide by 2. And if we go ahead and do that, we end up with n cubed plus 6n squared plus 11n all over 3. And can we go any further? I would probably leave it like that. We could factor in n from each of the terms in the numerator. Maybe that'll make it a tiny bit simpler. So n bracket n squared plus 6n plus 11 all over 3. And I think that's a decent place to call it. So we used the two results that were given to us to start off the question. We started off by simplifying the two factors that were inside of our summation, inside our sigma notation. Then we separated each of the 3 terms into their own individual summations. And then we started putting everything together over a common denominator, simplifying down, factoring a little bit, and there we go. So I hope this helps. I hope you guys are starting to get used to sigma notation, the kind of properties we can use to manipulate the expressions around to our liking, and so that we're able to algebraically manipulate different expressions, different summations. If you guys have any questions, comments, suggestions for any future videos, geometric series, more arithmetic series stuff, please do let me know in the messages below. Hope this helps. Thanks for watching.